I'm going to call this project June 6. Make an empty project, Visual C++ empty. I know I'm going fast and I forgot that you weren't here Monday, so that may have been too fast. What I did is new project, chose Visual C++. I had to, perhaps expand a few things to get to it. And then I chose Visual C++ empty project. I chose OK. And I named it June 6. So I'm going to right click on the Solution Explorer, and if you don't have the Solution Explorer, or if it's in a different place, you can't find it, you go to View, Solution Explorer. That'll bring it up. And then right click on Source Files, and we're going to create a C file rather than a CPP file, which is what it's trying to get us to do. So I'm going to do New Item, and where it says source.cpp, I'm going to make a C file instead, so .c rather than .cpp. June6.cpp.
Is this the principal marketing class?
Do we need to get out of here?
No, I'm asking because I don't know what it says.
Okay, I'm not sure where your marketing class is, but no, this is a programming class.
Okay.
What room does it say that it's in, or doesn't it? Look. It's neat when his enrollment sheet doesn't show the room. Okay, so June 6. Only typed in C. I don't know why I typed in .cpp. All right, and here we go. And we're going to type in some boilerplate. And like I mentioned last time, it's to your advantage just to copy that boilerplate and put it on a notepad or something on your desktop. But it doesn't take that long. Include angle brace less than stdio.h int main parentheses in parentheses opening brace printf and we're going to change it a little bit. %s is going to go there. So hello space %s \n end quote comma quote world end quote end parentheses semicolon. And then we're going to do a return 0. Now, this actually is probably not going to do what we want it to do because it's not going to stay around long enough for us to see the results. So we're going to wind up putting a system pause in there. It's not the best way to do it, but it's a quick and dirty way. Yeah. So when I ran it, it used to be that if you did start without debugging, it wouldn't close it instantly like this. But for me, it's closing it even if I do start without debugging. So we got to fix that so that it hangs around long enough for us to see our output. And then I'll explain what in the world this printf business is. So if you've taken the C++ class, you probably know you can embed a system call in there. Only works on Windows. If you brought your Mac in here, you don't need it. You've noticed it's not already closing anything. So system, open parentheses, open quote, pause, close quote, close parentheses, semicolon. But unfortunately, it's probably not going to link. Oh, and for Pete's sake, it wasn't linking for me downstairs, and I had to figure out which library it was in. If you're getting an error, or if you get a problem, here is what you have to add to it to get it to work. You have to include another library. I don't know why I had to do it downstairs, and I'm not having to do it on this one. Who did it work for? Worked for everybody. Okay, fine. If it didn't work, you would add this. Include stdlib.h angle brace. This is for pause, or for the system function actually. Alrighty, okay. So it'll run now. It says hello world. Why did I do it like this? I wanted to introduce you to the idea of the %s. In other programming languages, printing out a number or something has been as easy as doing, you know, I want to print out that, and then I want to print out a number, and then I, you know, something like that. You could chain a whole bunch of things in C++. Similarly, in Java, system.out, you know, print line, and then, you know, you could print out hello, and then you could, you know, put, you know, like that, and print out a number that way. In Python, you could do a print statement, and you could put in, anyways, you know, you could mix letters and strings and whatever. We don't have that ability in C. What we have to do is you use printf, and then you use format specifiers to get other things to print out. Like if you want to print your age. Int age is equal to, hey, today's my birthday, I'm older than ever, 51. All right? So I'm going to add a print message to print that out. Printf, my age is %d \n, end quote, comma, age. Okay, and it said, hello world, my age is 51, just as I had hoped.
I got a question.
Yes, sir.
So how do you run the program and actually see, because it says attached, or it just attached to something?
Did you make a project?
You got to make a project.
Make a project?
You got to do file new.
Yeah, because when I tried to make a project, it just would, I kept pressing OK, but
And it wouldn't do it. Okay, that is a real drag. I don't know if it's only on this machine or what, but you got to move your project out of the admin directory. So choose browse and then create a directory on, you know, your desktop or the documents folder or something. Is anybody else having that problem? When you do create new project, it just flat out doesn't let you do it. You're lucky. You're sitting in the one machine that does that.
I think, you know how earlier you were saying you had to add that second library if the system wasn't working?
Yeah.
If you had it as a C++ file, you need that to do system.pause or system pause. But like, because mine was a C++ file and I renamed it to a C file and it works without the second.
Oh, so when I was doing it, I goofed and I had it as a CPP file. Let me rename that and see if that's the case.
And then
Take out the include. All right, well, that was a wasted 15 minutes of my time figuring that one out. Yeah, that's it. Thank you for noticing that. I don't like little mysteries. Okay, so you may run into problems like this. System identifier not found. And it says system is undefined. And you go, well, but I looked the code up. That's what it's supposed to be. I'm going to rename it back to C so I don't get that error. How am I renaming it? I'm right-clicking and choosing rename. Right. Okay. So then what do? You highlight system, you press F1, it takes you to a page that Microsoft says that they're no longer maintaining, but it is a help page for it, and since y'all are using a version later than 2013, it probably has it. Okay, it took me to the completely wrong version. Alrighty, so system function C. And then if you look it up, you can find out what library it's in, what header file it's in. And that's what I did, and I failed to show that to you because hitting F1, hitting F1 failed to work for me. Okay. All right, so that's well and good. Here's one more thing I want to show you, which is how to get input. Remember how easy it was in Python? We could do that and it would get input? No such joy. Okay, so instead of declaring our age as 51, we're going to just initialize our age to 0. And I know you're a little bit behind, so I'm going to try to slow down. And we're going to ask the user for our age. So why not? Printf. Hey, there's a print statement. That's interesting. That probably disables the use of %s and stuff like that. I have to check that out. Okay. So, what is your age? Question mark, colon. End quote. Now we're going to use scanf. Scanf is the keyboard scanner. It pulls, if you've used Java, you've heard the term scanner. Same idea. So scanf, and we have to say what we're going to read. We're going to be reading an integer. So we're going to use that %d again. Forgot to mention what %d actually does. End quote, comma, and then we have to use our variable name, but we have to pass in a pointer to it. So you can see why this looks a lot uglier than your Java code and C++ code and stuff like that. Okay. So what does %d and %s mean? These are placeholders that get filled in. We could put more than one placeholder on the same line. If we said hello %s, so that we could print out somebody's first name, we'd have to have a first name and then comma, a last name. So %s stands for string, anything between quotes. %d stands for integer. %f would stand for floating point, something that you defined as a float or a double. So why do we use %d here? Because the pointer to the variable that we're passing in is an integer. So we had to tell the scanf command what kind of data to expect. And I hope this works.
Didn't work. It says something about scanf.
And it's exactly what I was expecting. You think that I'm lying? No, I had to look this up too. What has happened is, subsequent to the versions of C that I've learned, scanf is a really risky function call. It can easily lend itself to what are called buffer overruns. And if you're in the cybersecurity program, you may be used to that term, buffer overruns. It's when you give more data than the program is expecting. And it can write past the end of the array that was allocated for that data. And so there's a safe version of scanf that has been created. But you're going to see a bunch of examples just using scanf, including our textbook. How do you get it to work? You can tell it to suppress that warning, but you're going to have to use a # command that we haven't used yet. And it tells you to do this. Use _CRT secure no warnings. Now I didn't get that to work, but you can disable the warning very specifically, that specific one. We're going to have to use another preprocessor command called pragma. And I don't even know what that's short for, if it's Latin or something like that. But what we're going to do is, before our int main, actually it doesn't matter, preprocessor commands could even be embedded inline in the code. But # pragma, warning, parentheses, disable, : 4996, which is the error message that is. Now that tells it, oh, while you're compiling, if you hit error 4996, it's okay. You know what you're doing. You want to write unsafe code? No problem. We'll probably switch over to using the safe versions of the scan command. But like I said, the book was showing examples in scanf, so that's what I went with. All right, age 45. Hello world, my age is 45. Okay, that worked. Why did I show you this? Because I want you to, practically by day 1 or day 2 of a programming class, you need to know how to print something and how to get input back in, right? Even if the book's not showing it to you at that point, you do need to know that. So yeah, this looks a little bit, alien if you've been using the more friendly languages, but that's how we do it. So get input, This sign means pointer. Ampersand means the address. Just think of A, ampersand as being an A, the address of the age variable. And we'll talk later about why that's necessary, but for you guys who've heard the terms pass by value versus pass by reference, C is a pass by value language. So in order to get data back out of a function, you have to do some tricky things. One other thing I want to mention that hasn't been true of our other languages is that C is particular about where you define your variables. What if I come down here and before my pause statement I wanted to do something else? I was going to create some different code. I wanted something to do with area. It's no longer going to compile. And you better not compile. Why didn't it? Oh, for Pete's sake. Okay, when I was using it downstairs, and maybe it was because I was using a CPP file and not paying attention to it, I had to declare all my variables before any of any other code, before my function calls, right? Here, it didn't care. So, I can't fully explain why that's the case. Keep that in mind, that if you get an error defining a variable mixed in with your code, try just moving it to the top and see if that miraculously makes it go away. That is something that we had to do in the versions of C that I've learned, but they have updated it, you know, several times. There's C99 and there's C2011, something like that, where they borrow things from C++ and try to make it user friendly. At one time, C did not even support this last slash for comments, and all your comments had to look like that. So then they borrowed that from C++.
Is there, I guess like in other languages, how you can just declare without initialization? In C, do you have to initialize?
Let's see if it works. My my answer is going to be no, but then we're going to prove me right or wrong. Why didn't it just say okay, you know? Rebuild project. System undefined.
Yeah, it said that, and then...
But it said it succeeded anyways. System undefined, assuming an extern returning int. Well, I'm going to put that back in there anyways then.
On the second line of mine, it says uninitialized local variable age used.
Now I'm not getting that one. And you're using a different, oh, you're using 2013 as well. It's only the people who brought in their laptops are using a different version.
I'll fix it. I see why.
Oh, did you?
Yeah.
It was a legit error. Okay, so we did not have to initialize age before we used it with scan. What happens if we try to print a variable before it has been initialized? Yeah, so if we do this, int, you know, weight, and then we did printf, your weight is %d \n, end quote, comma, and then we typed in weight. Is it going to tell us that it's an uninitialized variable and refuse to run? That's what I want it to do. Yes, it did. Good. Error 4700. Uninitialized local variable weight used. Now I'm just going to play a little game with myself. And what happens if we disable that error? It blew up. Okay, it did compile it, but it failed to run. So obviously we don't want to disable errors. We want to think long and hard about what errors we want to disable. The reason I'm comfortable disabling 4700 is because it's just telling us to use a newer, safer version of it, but that doesn't mean that the older version doesn't work. Excuse me, 4996. So I'm comfortable disabling that error for us. But this one would be a really stupid one to disable. As we've seen, it crashes if you try to print something that has not been initialized. And what does initialize mean? Giving it a starting value, right? So whatever, I'm 51 what? I don't know. I'm going to delete those two lines. I don't want to make this example more complicated than need be. Okay, another thing I want to cover before we actually start looking more at the book and what they want us to cover. This preprocessor command, we've already got two of them. Let's throw in another one. # define name equals Bob. But don't put the colon there. That was my mistake. Don't put the equal sign there either. Now down here where it says world, replace that with names in caps. And so it says hello Bob. You see what it's doing? The preprocessor is the first thing that happens during the compilation stage. And if you have a # define, everywhere in your code you use that defined, I almost hate to call it a variable. I need to remind myself of what it really is. Tag, right? Every time it sees name, it replaces it in the source code with quote Bob. And like I said, it's not a variable. This would be flat out an error. It would not compile. If up here I did, don't type this because it's an error, name is equal to Joe, won't work, because, whoopsie, because this isn't a variable. Expression must be a modifiable L value. L value means something that sits on the left-hand side of the assignment operator, specifically a variable, and it's not a variable. Just something that kind of does a search and replace, and everywhere it finds capital name, it replaces it with Bob, but only for the purposes of compilation. It doesn't change your source code.
So like in C, there's like not strings, right?
Right.
So with the double quotes inside of it, how does it treat that? Like
That is a character array. Yeah, the question is, since C does not have a string class that we can use, what is that defining? It's defining a character array of ASCII characters. So, okay. Where else did I want to go with that? You can get nuts with these things. Like, what if we didn't like typing system pause? We're totally going to mess this up. # define pause in caps to mean system parentheses pause. Again, no semicolon. And then down here, I'm going to do pause, question mark. It's kind of like we're defining our own language, right? I mean, we're not. We're just replacing functions with predefined macros. That's what they're called, macros. But, well, I've talked a big game. Let's make sure it actually works. What is your age? 12. Hello, Bob. My age is 12. Press any key to continue. Now, for those of y'all who didn't even put a pause command in there, is anybody using a non-Windows computer, or can I stop saying? Okay, what are you using?
I use Linux.
Pardon?
I use Linux.
Oh, okay. Well, that's totally cool. But here, you didn't bring your... Okay. All right. But anyways, at home, you're not going to be putting pause commands. That's not even a valid Linux command. Okay, that's cool. All righty. We could replace pretty much any of this stuff with macros. I think that's about enough. I don't think I want to monkey with it anymore, but I wanted to show you preprocessor commands. There's one more which is kind of useful. #if_def. So up here at the top, I'm going to add one more thing. #if_def name. Has name ever been defined? Okay, it's giving me an error about that. The end if is missing. That's true. Okay. In that case, printf name is defined \n end quote. else printf name is not defined. $endif. So you can tell what's going on there. If this macro has been defined, it's going to print name as defined. else it's not going to do this. Now the editor, being super smart, knows that it's defined, and so it's graying this out to indicate that, you know. What if we mistype that, you know, and added an E there, right? And so it grayed that one out, and this is valid code. So the macros, the preprocessor directives, are in effect, you know, kind of its own language. I don't think you could seriously write a full program with it, but you see what I mean, right? Now, if we did not have a name defined, then the code later on, you know, wouldn't work. When you define something so that you can use if-def on it, you don't even have to give it a value. I'm going to show you that, and then I'm going to remove it. It will no longer compile because, you know, name no longer exists, but it didn't flag this code as an error. # define name creates a macro called name, but it doesn't ever get replaced with anything. So this # if-def actually still works. Quite often, you put your preprocessor definitions not up here at the top of the code, but in a header file, and then you # include that header file.
You said like the macros aren't variables. Could you pass input to define a macro like in a program?
Absolutely. Well, yes. You could write a macro that will accept parameters. Yeah. And good idea. I was going. Let's get to that point. I'm going to go and hit the PowerPoint that I've made over preprocessor commands. So if we go to Unit 1, there should be C PowerPoint 1. It's got some other stuff in it that I just kind of got grabbed along when I grabbed this PowerPoint, but specifically I added the things about the preprocessor. Our book doesn't introduce this stuff until like chapter 12, something like that. I think it ought to be almost the first thing we talk about. Okay, so I tack this on. You may have to add this to get your code to get to something to compile. So what is the preprocessor? The # is a special preprocessor character. It tells the preprocessor to perform some action. In fact, all preprocessor directives are prefaced with that. Moreover, you might be surprised to learn that the preprocessor language has its own language that can be used to build symbolic constants and macros. So, you can use it to create symbolic constants. We did that. Remember with name, # define number 7. So when the preprocessor runs, everywhere that macro occurs, it will be replaced with the value 7. And here's our example of that. Lucky number. So follow 2 rules. 1, make them all caps. Do you have to? No, but that's just standard. It's so standard that people will look at you cross-eyed if you don't do it. And 2nd, do not attempt to reassign data to symbolic constants. So here, this is an error. Number is equal to 5. Why is that? Because what does number get replaced with when the preprocessor runs?
7.
So it says 7 equals 5. Nah, 7 doesn't equal 5. You can't overwrite the value of 7 with the value of 5. So that would be a syntax error. All right, not that we can read this, but our preprocessor directive C statements, no, they only change the code. Yeah, they change the code, but the code that it creates when it's done had better be valid C. Why do we not use semicolons? Because the semicolons would wind up actually being in the code, right? So if I went back to my code here and I thought that I needed to put that there, then when it ran, name down here would be replaced with Bob, right? Like that. That's a syntax error. So the preprocessor language does not want semicolons there, although you could add them if you knew what you were doing, just like our system pause command. We could have put a semicolon there, but then we should take it out there. That looks even more wrong. You can do some really wrong things with your preprocessor. You could try to make your code look pretty weird. You know, you could replace all your printf commands with some other, you know, something that looks like a function name but isn't. But we're not trying to make our code as weird as possible.
Can you redefine macro? Like after you define it once?
Yeah, let's find out.
Is that like the
Define name is equal to Sam.
I mean, like, I guess you don't want to use it like variable, but
No, we've proven that you can't store a new value in it down in your code. You can redefine it if you want, but you can't assign a new value to it, if that makes sense, because it's a constant. So just like when if I did # define age is equal to 7, whatever, 8, and then I went down here and I tried to say age is equal to 10,
yeah.
8 cannot become 10. Whoops, semicolon, have it, bad, alrighty.
So you don't have to use the equal sign. I mean, I'm just saying, looking at it, like originally we just had.
You're right, you're right. And is it even working with my changes to it, adding equal signs? My guess is no, it shouldn't run. Of course, it's going to prove me wrong. Okay, you can't redefine a macro. That's one useful thing that we've learned. I'm going to take that out. All right, that's totally wrong. It shouldn't be doing that. That is correct. Okay, if we wanted to figure out why that worked, honestly don't know, because that's a syntax error. Maybe it's been programmed to ignore the equal sign if one exists. Not sure. Don't put them there.
Oh, that's why. So we didn't have the thing there.
That would be why. Because I wasn't even using the variable or the macro. Yep, okay, good. My faith in the universe is restored. Don't use equal signs. All right, so here's an example of writing a macro that accepts input. We're going to create a macro called area that multiplies length by width. So what we did is we defined a macro, parentheses. This is all part of this, but the macro is saying you better give me two values, L comma W, and here's what I want you to expand it to, L times W. So when it runs, I don't know if I can actually replace this. Yes, I can. This gets replaced with L times whatever they were. Yeah, length times width. It gets replaced. The preprocessor replaces that call to area with this, which works. So you define your parameters there, and you can use them in the code that follows.
Is that normally how you would do a function, or is it?
No, that's not how you normally do a function. This is if you want to create a macro that mimics a function. And I guess the only time that could be advantageous is if the function that you're trying to emulate is small enough to fit in a macro definition. Every function call does have some minor price in terms of memory and processing time, because when you enter the function, it's got to stick some stuff on the call stack, and then when you return from it, it's got to undo that stuff, from unwind it on the call stack. So I wouldn't define my functions that way, but you can. For example, let's write a function called squared. # square. Excuse me. # define square parentheses x, and what is the function? X times x. Then if you wanted to, you could do int whatever. X is, I hate using x again because that makes it look like it's related to it, and it's really not. Int x is equal to the square value of 10. Something like that. And when the preprocessor runs, that call to square is replaced with this macro.
What's funny is before you even said to start doing that, I had already started doing that.
Oh yeah.
I've had too many of your classes.
And so here's an example of an entire program that would ask the user for the length, and then use scanf to read it in. Ask the user for the width, use scanf to read it in, and then use our area macro to calculate the length and the width, and then to print it out. Okay, now why not just multiply length times width right there? You could do that, but having it defined as a macro tells you exactly what it's doing. Just like why you create functions. One reason that you use functions is it makes your code look a little bit more readable, hopefully, by giving names to the blocks of code that you want to execute. Now, for something as easy as multiplying two numbers together, would I use a macro for it? Probably not. And by the way, all this stuff works in C++ as well. And I really think that I'm going to, in my C++ classes from now on, start hammering on this too. Alrighty, that was the end of the preprocessor stuff. We will have a little bit of a homework assignment based on these ideas and using scanf, printf. So you'll want to keep your code with you, right? You know, you can always re-download your code, but there's a bit of a problem doing that. Let me see if I can demonstrate it. And if you've taken C++ already, you know this business, you know this drill, which is, oh, I don't have it. But if I had a submission and it was a .c file, I would click it, I would download the C file, and then I would double click it, and I couldn't do anything with it. Here's how I'm going to find it. I'm going to right click on the solution, do open folder in File Explorer. I'm going to go into my project folder. There's a .c file, but watch what happens. I double click on that, especially if I'd close my project, my solution. Let me do that. Alright, so even if I didn't have Visual Studio loaded at all, or if I did, pull it up, cool deal, ready for me to edit, there's no way to run it, right? And this is what you were seeing. There's an attach command, but that's all. So that's not good. What you got to do is you have to have the whole project. You can zip the whole project and unzip it, or you create a new project, you paste this code in, right? But you are going to want your .c files, you know, so that you can reference them when you're doing your own work.
But you can still run them in like Sigma, right?
Still run them what?
In Sigma that you're telling us to install.
Yeah, but you're going to have to compile them, right? I forget the command is gcc space file names followed by -o and the output file name. Right. So yeah, you can do that. So the fact that we're using this nice, great big fluffy IDE actually makes it, you know, people wish that they could open that .c, and I wish there was a make project from this file, you know, command, a wizard that would then run and make a project from what you are currently looking at. may have accidentally put that PDF in the wrong place where you can reference it. All right, so what are we covering in Chapter 1? So far, we've covered Xscape sequences. The only one we've covered is /n. So already we know that we have to have a main function. No C program will run without a main function. No C++ or C# program will run without a main function. Now, if you use some kind of wizard that creates a framework for you, like something that's going to create a user interface or something, there still is a main function, even though you don't really know where it is unless you go digging for it. So the building blocks of our basic programs. # includes will pretty much always have a # include. Do you have to have one? Well, not if your program is just adding two numbers together, right? If it's doing pure math, simple math, then you probably wouldn't need # include. But if it's communicating with the user, you need to get standard io.h, and there are a lot of other libraries you can bring in as well. So comments. The old school C style comment is the multi-line comment that begins with a /*, and then you can put in as many comments as you want and then end it like that. So you could use that for one-line comments. For that to work, we would have to put the /* at the end, right? So this is an error. Here's another one because that's a close comment. Now, something that is annoying about multi-line comments is that you cannot nest them. Right, so if I come up here and I decide that I don't really like this bit of code here, I don't like this stuff about the age, so I'm going to comment it out. I can comment the whole thing out by doing that, and then coming down here, I'm going to move this age thing here so it's all part of the same code, right? There. Good enough, right? Now when I run the code, that's not in it, and all it's going to print is hello name. But what if I decide later, well, I'm going to comment out a lot of stuff. And then I'm going to come down here and uncomment it out. Notice, I didn't have to add a closing /* here. It's not recursive, right? It's not like braces. Once you open a comment like that, it doesn't care how many more of these it finds. As soon as it hits one closing thing, it considers the comment done. And now that's an error, right? I mean, you can't see it maybe, but that's black. It probably won't even compile because it thinks that there's a closed comment that's not, associated with the open comment symbol. So just know that you can't nest multi-line comments like that. That's why, let me fix all my changes here. That's why typically if people comment out code, they use a single line comment like that. Multi-line comments are appropriate like for header blocks, and something that you're sure is never going to be commented out more than what is already commented out, but you can't nest them. So keywords, we know what the idea of keywords are. They aren't functions. They're the actual language itself. And you cannot use them as variable names, right? So you can't do case equals 3 or int case equals 3. It's too bad. Case is a pretty cool, name. You might want to use it, but you can't. So you can't assign values to them. You can't define a function called continue, right? You can't define, a variable named float. Something like that. I expect that it would give you an error if you tried to declare macro as one of these things. How about # define for to mean 13? Well, whatever. Is that going to compile or not? Well, I closed my project, so obviously it's not going to work. Let me close that solution and get back into the old one. And so, by the way, if you're going to edit one of your old files, you can't go to recent files and edit it that way inside Visual Studio. Why? Because again, you're just getting the C. You're not getting the entire project, this entire solution that has all the make files and stuff in it. So whenever you open one of your projects, you have to open it as a solution. Whether you go to the user interface and double click on the solution file, or whether you go into recent projects and do it that way. Okay, so what was I trying? Yeah, # 4. Is that going to even compile? It might. And the reason for that is that although this is a keyword, the macro language takes precedence, right? And once the preprocessor is run, none of this stuff is in the code anymore. Everything has been replaced. All the macros have been replaced. It has none of this stuff in it anymore. And so this bad usage of 4 is not in there.
So if you put 4 in the code.
But if you put 4 in the code, let's this is not going to work. You know, if y is equal to 3, do something. It's complaining now. Why? Because when the preprocessor runs, what does if get replaced with? The number 1. So it's going to say 1, parentheses, y is equal to 3, which doesn't make any sense. You could write a function that would evaluate, you know, an expression here. But no, we're not going to talk about that. Okay, so get rid of that. Get rid of that. You can't use a keyword in any other context except a keyword. They are reserved words. We're already pretty familiar with that from our other languages. You may already know most of these words if you have taken a C++ C# style class. In Java, you probably know 3/4 of them as well.
Auto? That one, I don't.
Auto lets the compiler pick the data type. Like auto f is equal to 3.14159.
Oh, okay.
What does f have to be? It's got to be a float or a double. I'm not sure which it's defaulting to. In Java, it would default to being a double. If we added an f there to force that constant to be an f, to be a float, then we'd absolutely know that f is going to be right. And so if we did this, auto u is equal to, you know, unsigned long, that's one of our data types, unsigned long. It's an 8-byte data type that doesn't support negative numbers. Then u is at this point an unsigned long variable. I don't know why to use that, honestly.
Like, I read somewhere, like in some C# documentation, that they tell you to use var instead. I mean, just for all of your variables.
Right.
So I guess you can put anything in it, I guess. Like if you have an int in it at that time, but if you want to...
No, that's not true. Once it's declared, okay, now C# may be different, but I don't believe it is. Once a variable is declared, even if it's declared as constant, you're not going to be able to turn around and then give it a different kind of value. Now, an integer would work, right? But, yeah, that's not going to work. You better not work.
Go over one.
What am I doing? Yeah, it's under build derp, herpaderp. Oh, for Pete's sake.
That's what I was. I guess that's why they say, because kind of like Python, where you can, or whatever.
That can't be. That can't be. I deny the possibility that that's going to work.
Don't forget your semicolons.
Thank you.
Yeah.
Okay then.
I mean, I don't like it because I like knowing my data types are.
Right.
I've seen like them say in the documentation to use var over everything just so you can overwrite, put anything in anything pretty much.
Well, that's ghastly because that's making it no longer a strongly typed language, which is the benefit of using all these languages over something that's weakly typed like you know, JavaScript or Python. Well, what do you know? I'm going to have to research that further because the because that's horrible. All right.
I agree.
Well, heck, let's Google that up. Var keyword C. Not C sharp.
Well, yeah.
Oh, yeah,
and
yeah,
C.
auto keyword in C. It's a modifier like static, defines the storage class of a variable. Since the default of local variables is auto, you don't normally do that. Okay, that's moronic. I'm not going to waste any further time on it. Once the book hits auto, maybe we'll become vastly more illumined. For now, I would just say accept it as being a way to avoid having to give the type, letting the compiler pick the type. Wrong.
Defines local variables having a local lifetime.
So extern means that the variable that you're trying to use is not defined in your code right there. Right? What if you have .2.cpp file, two C files, and you have a global variable defined? Well, this file is not going to know about that other variable. And so in order for it to compile, you would use extern to reference it, to warn it. We do have a global variable defined elsewhere. So go ahead and compile it and then trust the linker to bring it in. Now register. This is kind of odd, but what you're saying is this variable is so important, so useful to me that I want you to store its value in a register. And I honestly don't know if that even works anymore, but it's still around, you know. To me, that in a multiprocessor system, that's a pretty weird idea because you have a limited number of registers on a CPU. You know, a register is just, you know, a couple of bytes dedicated to holding a value. And if you have a bunch of C programs saying, I want my data stored in a register, no, I want my data stored in a register, I don't know if they swap in and out gracefully or what. So, but for maximum speed, you might define a variable and tag it with the register keyword so that it would be stored on the register. Why? Because when, in terms of accessing memory and relative speeds thereof, probably not going to work. I doubt y'all are going to even be able to see it. If you have your CPU, registers are part of the CPU, so the data is practically instantaneously available to it. You know, in the order of, you know, a very small number of nanoseconds. And then you can have a cache. And then you can have your normal RAM. And then you could have your disk drive or your flash RAM or something like that. And it's kind of like each one of these takes an order of magnitude longer to access. So if it takes 1 nanosecond to pull something out of the register, it might take 10 nanoseconds to pull it from the cache. It might take 100 nanoseconds to pull it out of RAM, and it might take 1,000 nanoseconds to get it from the flash drive, probably even longer than that. So that's why disk drives will also have caches, so that you're not actually having to hit the disk drive every single time. There are caches available for the CPU, so that data from the RAM gets loaded in the cache, so that it's really quick to pull it out. So that's why you would want to say that, oh, I want to keep this variable on the register, so that I can access it within 1 nanosecond rather than 100. Or if we're lucky, having it cached and accessing it within 10.
Could you think of a variable that would be that important? I mean, I guess since it's trying to talk to hardware, I mean,
Let's Google why use register keyword.
I can't think of anything that would be weird.
Registers are faster. The variables that are most frequently used can be put in registers. It's a compiler's choice as to whether it really will or not.
So you can just like put it in.
Yeah, you can put all your variables in registers and hope that it speeds it up.
Let's make your program so much faster.
Okay, I'm not going to research why. If you're curious about it, Google it up and see why.
says using register will win you nothing because the compiler decides. So I guess maybe I don't know.
Yeah, I think that was like, you know, back in olden days you didn't have. Yeah. Back in olden days, you had very slow computers. I mean, they may have seemed fast at the time, right? And they were single use. You only had one process running at a time. And so storing data on the register would allow it to run more quickly. And, you know, you wouldn't be sitting there waiting as long for it to do what it was going to do. And I think that processors are so fast nowadays. Okay, we know what return does. I'm saying we know what. It's possible you don't know, but that's okay if you haven't taken C++, but that's okay because we will cover these things. Volatile is a keyword that you will not have seen before, most likely. Volatile marks a variable as being something that could be changed from outside the code. What does that mean? It means that when that variable is accessed, the code makes sure that nobody else is accessing it at the same time, that it cannot depend upon that value. It has to reevaluate. It has to go back out to memory and grab the value of that variable every time rather than do some sneaky optimizations. Because the C++ and the C compilers try to optimize the heck out of this code so that it'll run as fast as possible. Because that's why you're writing it in C or C++ to begin with, is to get your code to compile quick. I mean, not your code to compile quickly, but for maximum performance. I doubt we're going to use Volatile. We're not going to have the circumstance in which to do it, but you just might tuck it away in your brain. So Xscape Sequences. We've been using \n, and \n corresponds to an ASCII character, I believe 10, the ASCII value for the byte value of 10. And it just means go to the next line. So this would print out, go to the next line, see you later, and then go to another line. There are other ones. Tab, \T. We probably use this in some of your other classes. It just inserts a tab character. You can use that for cheap and easy formatting of your data, you know, when you're trying to space it out. Is it the great way to do it? Probably not, because if an element of data is too long to fit in that tab, it goes ahead and tabs to the next one, and then your data becomes very ragged looking. So /r returns the cursor to the beginning of the current line, and it'll overwrite it. // will insert a \. Why is that necessary? Because if a slash means something special is coming up and don't print that slash, you do have to have a way of telling it. Sometimes I really do want a slash. So, for example, why does that happen? When does that get used? What if you need to specify a path? # define file name as being, you know, C:\\/ system / file.txt, something like that. Let me pick better examples. Temp new.txt. What would /t mean? That would be a tab character. What does /n mean? Go to the next line. So yeah, that totally messes it up. And if you actually need a slash in your output, that's one way of doing it. There's another character that I forget, which if you define the string, you know, it's not underscore, but that's giving you the idea. If you tell the compiler, oh, I want you to do this as a strict string without any, but that's why you would use //. And there's other ones. There's /quote. Why do you have that? Or /double-quote? Because what if you wanted to say, yeah, down here, your name is %s and mine is Joe. You can already see the problem there, right? It's interpreting this as the end of the string. And so that garbages the rest of it up. If you want a double quote in your output, you have to do that. Or You just think to yourself, I'm going to replace that with apostrophe so I don't have to worry about it. And that worked. You could do that, right? As long as you're not, putting the same type. And the same is true of characters. If you define a character and you wanted to be able to, to define a character, you have to use single quotes. You have to use apostrophes. But what if the character you're trying to define is the apostrophe? That would look like that. That's not going to work. So you use a / apostrophe in order to say, well, I really want ch equal to an apostrophe. Almost time for us to stop, and we're going to need some homework. All right, so homework. Write a C program that uses scanf and printf to solve the following problems. And Adrian already knows I know what you're going to ask me to do because he's taken like 5 of my classes. All right, so ask the user for a radius and calculate the volume. No, the area of a circle of that radius. Calculate and display. Let's remind ourselves how to get pi. And when I say remind ourselves, Google it up. You could always just use 3.14159 and I would be happy. Pi defined C. Math.h. Let's give that a shot. Make sure it actually works.
Right.
# include math.h. And down here I'm going to say float z is equal to m_pi. Did I get that wrong? You know what I'm going to use is 3.14159. It's probably in C math instead. I'm not going to take the time to figure it out. Okay, so in your programs, if you're going to use math, you can just do this. Float pi, or even better, let's make it a macro. Pound define pi as being 3.14159f. It's a floating point number. That's not strictly necessary because it assumes. So I'm going to take that out. So for pi, add this define to your program. All right, and then ask the user for temperature in F and convert it to C. The formula is C is equal to F minus 32 divided by 1.8. There are other formulas. If you've already got them memorized because you've taken other math classes, feel free to use those instead. Ask the user for temperature in F. Then use an if statement. Not that we've demonstrated that, but you probably know what an if statement is. Use an if statement to see if the temperature is below 32. Actually, we could do that on the same ones as here. 3, use an if statement. If the temp in F is less than 32 degrees, print ice ice baby. Remember, you don't use the print command Although we saw a print command, it might just do the same thing as printf does, but without the substitution. You can give that a shot. And if the temperature is greater than 212, print steam. Because I couldn't think of something funny to talk about steam. Okay. That makes sense. 3 little things. You can write it all in one program. So just write that up and submit it to the Dropbox, which I will create. That makes sense, guys?
Is this on the recording?
It will be out in D2L. Not there. I have to upload the notes. I always create custom homework because students will upload homework assignments to websites and then they can be downloaded by other people along with the solutions. I haven't found many of my homework assignments up there like that yet, but it can happen. Alright gang, we are done. If you are happy, let's make a Dropbox for what we typed in today, if you did, and upload to it.
You just want the C file, right?
Right.